So honestly, in my opinion, everything we've done so far this chapter has been the easier stuff. Again, you got to be a little bit of diligence, and all that stuff shouldn't be a problem. I don't think there's anything that we've done so far that that you don't have the capability of doing. Now, you might not review and therefore forget something. Okay, well, that's on you. But I don't think there's anything we've learned so far that you have a problem understanding. Here, though, you got to be careful that you get down what we're trying to do, because we got to deal with a couple situations. Okay, the first one is dividing polynomials. And in this first situation, we're dividing a polynomial. We have a trinomial on the top, and we're dividing by a monomial on the bottom. So that's this part, dividing with a monomial divisor, meaning the bottom is one term. You have to recognize this because you treat a monomial divisor differently than you treat a polynomial divisor of bi, tri, etc. You have to do them differently, and you've got to keep that straight. So you got to go back and look at your notes and review and say, oh yeah, monomials you do this way, binomials and trinomials you do this way. Right? The rule is easy. We've really done this before. You have to separate it. So you got the A plus the B minus the C all over the divisor, the monomial divisor of D. That's how you treat a polynomial divided by a monomial. I mean, that's what you do. Now, we've done this before, so I'm not going to spend a ton of time, but I am going to remind you something. So, and of course, what am I going to put in the blank by the asterisk? Reduce when possible, right? Reduce when possible. Look, sometimes when you guys can't remember if you can do something or not, you need to learn how to make up your own example to figure it out. I do that. You're like, you're a math teacher, you've been teaching for 30 years. No, there's some times where I'm like, am I remembering that right? And I just make an example. So let me show you what I mean. This is what I see students want to do. If we had something like 4 plus 12 divided by 4. Students want to do this. To get a final answer of, two ways you can have a final answer right now. If that were the correct move, the correct answer would be 13. The further wrong answer would be 12, because what's 4 divided by 4? 1, and 1 and 12 is 13. All right, so, if you want to do that, you get 13. Now, let's do it without dividing the 4 in. 4 plus 12 is? 16 divided by 4 is? Oops, I must have made a mistake. That must not be the way to do it, because we all know 16 divided by 4 is 4. Okay, I took care of the issue. Therefore, if I had something like this, x plus 2 over 2, I certainly know I cannot do that, right? I can't do it. I just tried to do the exact same thing I tried to do here, and it didn't work. It doesn't work. You can't do it. It's not how you do it. You can't divide this 2 into that 2. And the reason is this top is one term. It's a binomial. It's one thing. The x and the 2 are tied together by addition. And you just can't go dividing something into it. Now, if you had a problem like this, 2x over 2, that's a horse of a different color. This is a multiplier of this. This is one term divided by one term, and you can divide those 2's. And again, if you don't know, you can do an example. 2 times 5 over 2. 10 divided by 2 is 5. I should get 5. 2 divided by 2 is 1. 1 times 5 is 5. Oh, it works. I can do it there. But you have to learn to do that with some simple numbers if you're not remembering which way it goes. Just do some simple numbers and do an example and get it figured out. All right? But this will kill you. And why am I telling you this? Because how many students have I seen over the years get killed by doing that mistake? Over and over and over again. They do that mistake. You can't do that. You got to split it up. And later on, when you get to Algebra 2, we'll have quadratic formula, and students will try to do this. All right, can't do that. Doesn't work. Doesn't work. Doesn't work. Let me get rid of all that mess. All right, so let's go on here. I mean, these problems, look, we've done these. I'm only doing 2 with a monomial, and we're moving on because we know what to do. If I were going to do a shortcut in B, I would cross this out, I'd put it under that one, and I'd put it under that one, right? So I have 2 fractions now, correct? With a minus in between. Now, if you don't like the shortcut, rewrite it. It's 2 fractions. Knock yourself out. So all this is, from here on out, is a reducing problem. So go ahead and reduce it. We've done this before, this old hat. Go ahead and reduce it. And I hope that's what you got, right? Because 12 divided by 3 is 4, n squared divided by n is n, minus 9 divided by 3 is 3, n divided by n is 1, minus 3, right? How many got that? Whoa. All right. How many got that? What are you missing? You better start asking questions here. Why did you not get that? Questions. Alexandra?
Why doesn't the variable stay on the 9 and 3?
So if I separate that, Alexandra, it looks like this. So technically, if I went every step, this 9 is a 3 times 3. And anything divided by itself is a 1. But you knew that. You got the 3, right? Well, the n is the same thing as a number. I mean, maybe the n actually equals a 3. Maybe it equals a 7. Maybe it equals an 11. But it's like an 11 divided by 11, a 5 divided by a 5, a 6 divided by a 6. So this n here divided by this n here is a 1 as well. They divide it out. But on the left-hand side, you had an n squared, which is an n times n over an n. And one of them went away, and it left one more left on top. Okay? We're just dividing things out that are same terms. Okay, so now that we did that, see if you can do C. Just be careful with that negative in the bottom. Hopefully you'd all started off like this, right? So go ahead and see if you can get this one. You won't mess up the variables on this one because there are no variables on the bottom. Right? So negative 5y squared plus 7y minus 10. That one a little bit easier because it's just numbers, right? Is it possible to still have a fraction in a spot as you're doing this? Yes. And you know what? I better give you guys one more quick example lest you make the common mistakes. Let me give you one more. We'll do a simple binomial. How about let's do 10n squared plus 5n divided by 5n. Go ahead and solve that. 10n squared plus 5n divided by 5n. See what you get with that. Sounds like Quantico is cranking up today. 10n squared plus 5n divided by 5n. I don't have a problem with you guys doing that to your original on your homework papers. If it were a quiz or test, that's what I would do. Saves time rewriting it, and quiz and test time saver is important. So hopefully everybody agrees the front is 2n. Is that it? How many have 2n as the answer? Okay. That's the exact same reason why in the beginning my opening was 13, not 12. Because anything divided by itself equals 1. And the 1 matters here. You got to have plus 1, or you're going to miss that. All right, don't make that mistake. Don't make that mistake. Anything divided by itself is 1. There you need the 1. Look, a lot of times you don't need the 1 because you're doing multiplication in part of a term. Look here, when you did n divided by n and got 1, it's 1 times this stuff. What's a 1 times a 2n? A 2n. So there, the 1 didn't matter. But when it's plus and it's all 1, now it matters because this is 1. So you got to remember that. All right. Hopefully you'll be good on those. Be careful on your homework. Those of you that, that's a little bit of a chore to you, you got to really use your odds to make sure you know what you're doing. Let me get rid of my shade so I can go to the top here. Okay, so here's the other situation. Dividing with a binomial, or let's say, I'll do binomial. I don't think we're going to do polynomials today. By a binomial divisor. And by the way, it could be a trinomial. Could even be a 4-termed polynomial. But we'll start out as we're on with binomial divisor. You have to solve this by long division. Now, I will tell you this. There's a shortcut called synthetic division. And it does work. But it has its limitations. Remember a couple of days ago when we were doing multiplying polynomials and I said, why use the trick of the FOIL method on the first first level of multiplying binomials instead of learning how to distribute so you can solve any polynomial times polynomial instead of some trick called the FOIL method, which only works on a binomial times a binomial. Well, let's learn how to distribute. Now we can multiply any polynomial times any polynomial. Learn how to do long division. Then you can divide any polynomial by any polynomial. But synthetic division is a shortcut and has limitations. So I don't even know if your book gets into it or not. Some student might say, hey, synthetic division, man, piece of cake. It'll knock that out in a second. And it will. But if you only learn how to do synthetic division, as soon as we get the situation where you can't use synthetic division, you're stuck. And again, you would have missed learning the principle on the easiest level. So you can do the more difficult levels. You guys understand? All right, so long division, it's not hard. We all know how to do long division. I think we started in, I don't know what grade. Third grade? Second, third, whatever. So we're going to do long division. All right, cool. Long division, we can do that. First off, we need to change the form. Now, by the way, before we do anything, you can't be doing stuff like this for the reason I started the whole lesson with, right? You can't be doing stuff like that. Oh, cool. X squared minus 8 minus 10, so x squared minus 20 is the answer. No, it's not the answer. Can't do that. Because everything on the top is one thing. It's all added together. It's one term. And everything on the bottom is one thing. It's one term. You got to take it as a whole or nothing. And so you can't do that. Can't do that. Can't do that. Can't do that. Okay. So we're going to do long division. We're going to take the divisor, the x plus the 2, and we're going to set up a long division. We're going to divide it into x squared minus 8x minus 20. So set yourself up. Now, while we're doing this, I'm going to off to the side refresh your memory on long division. Okay? So you don't need to write this in your notes. I'm just going to use it as an illustration to help jog your memory of what to do. All right, let's divide 7 into, I don't know, 537, I guess, whatever. Okay. So, if you were doing the 7 divided into 5,037, the first thing you do is up top you would put a 7. And you would stick it here, right? No, you wouldn't, would you? You would stick it here. Agreed? I would. All right. Why did you pick 7? Okay, so there's two ways of thinking of it. 7 times 7 is 49, right? And so you gotta divide the 50 by 7, yes? How many times does 7 go into 50? 7 times, because 7 times 7 is 49. So here's how these go. Take your color, take your green. All you're worried about right now is the front term. It's the first one you come to. And you want to divide it by your front variable. So I'm going to do this off to the right on the side. So here's your first thought. What is x squared divided by x? Because watch, what did we do? What is 50 divided by 7? It's 7, right? What is x squared divided by x? That's easy. The answer is x. Now, where do I want to stick the x? I think your book sticks it there. Is that where you want to stick it? I don't want to stick it there. I never stick it there. Okay? And the reason I don't want to stick it there is that's the squared column. And it's a x to the first power. And I don't want it there. I'm just going to stick it in the column that it belongs in. And that's the x to the first power column. I'm going to stick it right there. Do you understand the concept? This is x to the first power. So I'm going to stick it over the term that has an x to the first power. It's going to help keep things orderly for us. Okay. Let's go back to 3rd grade. Would you agree the next thing you would do is 7 times 7 and say 49? Agreed? So do you understand the next thing to do is to say x plus 2 times x? Does that make sense? Same thing like long division, right? Okay, so somebody tell me, what do you get when you multiply x plus 2 times x? John?
X squared plus 2x.
How many agree with John? X squared plus 2x. Yeah, exactly right. You're distributing. X times x is the x squared. Positive 2 times x is a positive 2x. You're just distributing. Again, if you want, you can put the x in front, but you have to do that every time. It's so much easier to just, again, front x times x is x squared, back, positive 2 times x, positive 2x. Okay? All right, let's go back to 3rd grade. What would you do next? You would subtract, right? And say, oh, I get a 1. So what must we better do? We better subtract. Isn't it? It's that exact same thing, right? Subtract. So what do you get for a remainder on this one? On the left, I got 1. What do I get here? What do I get? You better get a negative 10x. Because we all know when a negative's out in front of a parentheses, we better distribute it, right? 95% of your mistakes are going to be on distributing this negative and adding these two up. 95% of your mistakes. Here to this extent, this is what's going to happen tonight. Some of you aren't going to distribute this negative. You're going to get something else here. You're going to finish it. It's going to be an odd. And then you're going to write, you're going to get the whole thing done. It's going to be wrong. You're going to look it up in the back of the book, and then you're going to do this. That's what you're going to do. Did you know what you're doing? You knew what you were doing. You figured out all the procedures. You made a mistake. You didn't distribute the negative. You made a mistake. You're not stuck. You made a mistake. Do the problem again. Maybe you won't make the mistake the second time. But that's why you got to cross out the problem and do it again from the beginning a second time. Because if you look, you know our brain, right? You know how our brain works? Have you ever said something, you thought you said it, and you were adamant, I said it, and everybody else says, no, you didn't say that, you said this. How many of that's happened to you? Yeah. Every teacher it's happened to, because we talk all the time. They're like, no, I didn't say that. Like, everybody's like, no, you said this. Like, no. Because our brain does things. And you look at what you did, and you'll make the same mistake again, more often than not. So then you're like, oh man, I'm stuck. I don't know how to do these things. And you're like, the rest of the assignment, you just waste your time. I don't know what I'm doing. This math is always so hard. I can never figure this stuff out. And so now you're negative thinking the whole way through your homework. Oh, this stuff, I don't know why. I don't know how he expects us to learn this stuff. It's impossible. And of course, then you won't learn it because you got all this negative brain energy going on. It's just a mistake. All right. We all know how to distribute negatives. We can do that. It was a mistake. Don't make the mistake. 95%. You'll get it wrong on doing something like that. Okay. Let's go back to our third grade. So next we would bring down the, and here I'll cut this one short to go more with our example. We'll bring down the 3. So on the right, what are we going to do? Bring down the negative 20. Sure. And now on the left in third grade, we're going to think 7 goes into 13 how many times? Once. And we're going to put a 1 up here, right? So can you figure out what to put up top on this one? How in the world do I get that stupid box away from there? It drives me nuts when it does that. Oh, well. It'll go away sooner or later. All right, so watch again. Front, use your blue, divide it by front, right? So now off to the side, we're doing a negative 10x divided by an x, yes? Front term divided by front term. Negative 10x divided by x is? What is it? Negative 10. What goes up top? Negative 10. Back to third grade. 7 times 1 is 7. On ours, what's x plus 2 times negative 10? Go ahead and multiply it out. X plus 2 times negative 10. You should get negative 10x minus 20. Back to third grade. Subtract. Oh, we end up with a 6. I'll deal with that in a moment. Again here, subtract. Distribute the negative. Distribute the negative. What do you get? 0. Beautiful. Love it. Wanted 0. 0's cool. No remainder. What's x squared minus 8x minus 20 divided by x plus 2? Answer, x minus 10. By the way, anybody know how to check your answer? Nick?
X plus 2 times x minus 10.
Okay, so I think he said x plus 2 times x minus 10. Look, this times this has to get you back to this, right? You guys know that, right? Right? For example, 12 divided by 4 equals 3. What's 3 times 4? 12, right? I mean, you know that relationship. This one we have a remainder. So if you were in third grade, you would do this, right? R6. What if we don't want to be in third grade? What if we don't want to use R? How would we say the remainder? Anybody know? Abby? Okay, so what would I write? All right, 6 over 7. With a polynomial, we'll have to add a plus or minus sign. I'll show you how to do that in a minute when we get to one with a remainder. Okay, so that'll come up in a minute. Let's do the second one. Come on, screen. Cooperate. All right, so I'm going to start off with red this time. So again, watch. Front divided by front. Right? Front. And again, I'm going to do this on the side so you can look back at your notes and remember what we're doing, right? And everybody knows that 6n squared divided by 3n is 2n. Where are you going to stick the 2n? Over what term? The 11n. All right. Again, some students prefer this front thing to be in a parentheses to keep track of the multiplication. If that helps you, use it. If you don't need it, don't use it. But now multiply the 3n minus 2 times the 2n. I don't know if you caught on, but your front term should always be exactly the same. This way, when you subtract, it goes away. And hopefully you got 6n squared minus 4n. Oh, and don't forget to subtract, right, and distributing that negative. That's going to give me 0. That's good. By the way, if you don't get 0 in the front, you chose the wrong thing to divide by. So now, what do we have on the bottom? 15n, right? 11 positives and 4 more positives, 15 positives. What's next? Say it if you know it.
Bring down the negative 10.
Bring down the negative 10. Come on, I should hear 26 voices saying that. Bring down the negative 10. All right? What are you going to do next? Say it if you know it. Divide by the front, divide it by the front. So we all know, hopefully, that is 5, right? Now, let me show you where some other students will get a little goofed up. They'll do just that. And I want to do a little more than just that. What little more do I want to do? John?
The positive.
Yeah, I want that plus sign there to keep track of everything in order. It's a 2n plus a 5. Okay, so again, we're going to distribute, multiplying it out. 3n times 5 is a 15n. Negative 2 times a positive 5 is a negative 10. And cool, when we subtract, again, we get 0 remainder. And indeed, a 3n minus 2 times a 2n plus 5 does equal 6n squared plus 11n minus 10. No remainder. That's the answer, 2n plus 5, long division. Let's get to a remainder. All right, so look, guys, it'll benefit you the most if you'll talk as I ask the questions. Try to think. Try to stay engaged. Okay. First thing you want to do is say it if you know it. Do what? What do you do? Divide what? What is it? Divide the what by the what? Okay. So the first divided by the first, so the x cubed divided by the x, right? And hopefully we all know that's an x squared. And where are we going to stick it? In the squared column, right? It's going to keep everything orderly for us. All right, do your multiplication, do your subtraction, and see if you get the same thing I get. Try to do it without looking up. Just look at your paper, you do it, and then look up when you're done. Distribute it. Do the subtraction. See if you end up in the same place. 2x squared, concur? Okay, what would you do next? Say it if you know it.
Bring down the negative.
Bring down the negative 5x, right? We're just doing long division. We know how to do long division. All right. Now, what do you do to figure out what goes up top? You do what? Say what? Do what? Divide what? Divide the what? So what is the first? Divide the what? So the front, the 2x squared gets divided by x, right? The front divided by the front. And hopefully we all know that this is a 2x. And we're definitely going to put the plus sign, right? You need that plus sign. It's a positive 2x. Okay, multiply that out and do the subtraction. Try to do it without looking up to see if you know what to do. Once you're done, look up, see if you got it right. Are you good? Next thing, bring down the negative 9, right? All right, Steve, you can do this next term all the way through to the end of the term. All right, do the next term all the way through to the end. Again, if you need help, you can look up. I'm going to use blue on this one. Try to do it without looking up if you can. Does division always end up even? No. What's 14 divided by 3? 4 and 2/3, right? You got a remainder. And sometimes in polynomials you get a remainder. So watch what I do. Because that's a minus sign, I need this minus sign to come after the 7. And then I need the 2 divided by what? X plus 1, the divisor. If that would have ended up a positive 2, I'd have the positive sign here and the 2 over x plus 1. You got to have this sign in between, because look, it's this plus this plus this plus this. Okay? So always the remainder. Minus goes right after the last term, and then the number over the divisor. Plus would go right after the last term, and the rest of the remainder over the divisor. All right. Try to do D on your own. I'm going to do it as you're doing it. If you need help, look up occasionally, but see if you can do D on your own. Again, hopefully you don't have to look up. Trying to go slow, not to get too far ahead, but I'm probably ahead. Again, don't look up unless you need it. All right, if you don't have time to finish it, just go ahead and write the final answer. You can go back later and finish it because I want to get to that last problem. Should have gotten x squared plus 8x plus 49 plus 228 divided by x minus 5. Hey, 5 times 50 is 250, but a 49 is 1 less. 5 times 1 is 5. I'm 5 less than 250, 245. But again, use your calculator if you need to. And then again, 17 negatives and 245 positives, right? So again, the plus sign's got to go in between. 228 over x minus 5. And again, I know some of you don't work that fast, and that's okay. Go back later and work. I want to get to this last one. Because in this last one, what if you have a polynomial divisor? And when I say polynomial, I really mean trinomial or larger. Well, same thing, long division. You can divide anything by long division. To be honest, you can divide with a monomial divisor by long division. It's just you get weird remainders, and we don't want to do that. Okay, we don't want remainders with a monomial. Okay, so look, we know what to do, right? Oh, all of a sudden it's a trinomial in front. I have no clue what to do. No, we do what first?
First by
Divide the front by the front. 2x cubed divided by 2x squared. Last time I checked, that's an x. Now you begin to see the value of lining things up. Where do I stick it?
that's
Over the negative 7x. Now I got to distribute the 2x squared, the plus x, and the negative 3, right? So 2x times x, 2x squared times x, 2x cubed. Positive x times x, positive x squared. Negative 3 times x, negative 3x. And next I would subtract, right? Distributing that negative to all three terms. Front term's gone. Second term, negative 6x squared, negative 8x squared. Beware, that's usually where the mistakes come. Negative 8x squared minus 4x. Bring down the 12. See how you're doing the same things over and over again once you get it down? All right, front divided by front. Negative 8x squared divided by a 2x squared is a negative 4. Goes right there in that column. And look, when you reach the end, you know whatever's left is the remainder. And rightly so. So, distribute. Negative 8x squared minus 4x plus 12. Subtract. Oh, beautiful. 0 remainder. Guess what? If you multiply a 2x squared plus x minus 3 times an x minus 4, you get that. All right, there's your homework. Again, I told you guys what will happen if by some miracle we're off tomorrow. I'll push everything back. The way we're planning right now, review tomorrow, quiz on Monday, test on Tuesday. If we get a snow day, everything will be back one day. Have a great day.